Hi and welcome to our tutorials on VG software. In this video, I want to show you how to use an Absolute Arm in combination with the AS1 scanner and VG software. I will be using VG metrology, but of course, everything I do can be done exactly the same way in VG Studio Max. My goal is to laser scan an object and do some basic measurements and tolerancing on it. So, let's get started. Here, I have an empty VG metrology project with my three 2D views and the 3D view. I can see that it's empty because there is nothing in the scene here on the right. To add a laser scan, I need to go to the CAD Surface Mesh tab and select Create Scan Object. This gives me two things: a new object in the scene tree and the Scanning tab. On the Scanning tab, we can simply work our way from left to right, and we should get everything we need. Since the scan object has already been created, I can go straight to Start Laser Scanning. Since the 2D views are not needed for this, the software automatically maximizes the 3D view. Up here on the left, you can see a blue circle. This circle can either be red when the RDS, which is Hexagon's interface software to the Absolute Arm, is not running, blue like it is right now, when there is no connection to the Absolute Arm, or green when everything is all right. If I bring up the RDS, you can see that yes, there is no connection to the Absolute Arm. Let me turn on the Absolute Arm. And voila! As soon as the connection is established, the circle turns green, and once the AS1 is detected, you will also see this icon, telling you that you're in the laser scanning mode. Let me get rid of the RDS again. Otherwise, it will just be in the way. And now I can start scanning. While I'm scanning, you can see the camera is following my movements, giving me direct feedback on what the scan looks like and where there are still some holes. The scanning is straightforward, but I will stop here real quick to show you a couple of things. As you can see, the VG cube is lying on the table. But of course, I'm not interested in the table surface. To get rid of the unwanted parts, I'll go to Clipping. The best options are either Clipping Plane or the Clipping Box. I will take the clipping box and just move it up a little, until only the cube is visible. If you have more unwanted things around your part, you can also change the size of the clipping box by moving the small yellow squares on each side of the box. And when I'm happy with what I see, I'll go back to Scan 1 in the Scene Tree to get back to the Scanning tab. This clipping of the unwanted parts is not only nicer to look at, but also necessary later on, when we create a mesh or STL from the scan points. Only the points that are visible will then be used. Speaking of scan points, right now, the preview that you see is already a mesh that is created live while scanning. If you're more interested in the actual points, you can change that up here. And when I zoom in, you can see all the individual points that are in the scan so far. The third preview option is patches. Every time I press and hold the trigger to scan, it counts as one patch. When I release the trigger, the patch ends. The next patch starts the next time I press the trigger. As you can see, so far, I scanned 3 patches. But let's say I'm not happy with the last patch. Maybe I scanned too fast. Or I included too many things around the part. In this case, I just push the tri-state button above the trigger to the left once. And the last scan patch disappears. I could even go one further and push and hold the button to the left. Then all the patches in this scan will be deleted. When pushing left deletes things, then it only makes sense that pushing it to the right creates something. And trying it out. Yes, it creates a new scan object in the scene tree. But I'm not yet done with the first scan, so I'll just delete this one and go back to Scan 1. Actually, let me finish the scan now. Alright. I'm pretty happy how the scan looks. The next step is to convert the scan points to an actual mesh. You can decide if you want a coarse, medium, or fine mesh, depending on what you want to do with it. If you want to actually perform measurements, it makes sense to go up to a fine mesh. I will go with medium and click on Generate Mesh. If I later find out that I still need to add to the scan, it's no problem to scan again and generate the mesh again, as long as the part hasn't physically moved in the meantime. Before I continue, I want to quickly show you how it works when I have two scans for a part that I want to combine. I will take a different part, so that I don't have to move the cube before tactile probing. And I will spare you the actual scanning. Here I am, with the two scanned halves. Now, if I had a CAD or an STL for the whole part, I could use that to align the halves. Since I don't have either, I will use Quick Alignment. It is important that I look at the two halves in a way where I can see 3 points that are in both scans. I'll go to Quick Alignment. Now I first select the points on the first half. And then I roughly select the same spots again on the second half. And voila! The two halves are quite well aligned. To combine them, I just need to select both and click on Merge Scan Objects. The 2-point clouds are now merged, and a mesh is also automatically generated using the selected preset. Looks good. Now I can think about measuring things, and for that, I will go back to my first scan. If there is a probe attached already, I can just press the Tri-State button and select Switch Down. And of course, vice versa. I can select Switch Up to get back to scanning. You can see in the green circle which mode you're in. But obviously, I want to be probing right now, which I can also start with this button. This behaves exactly like you would expect. I can create single points, or hold the trigger down and create multiple points. And just like I could while scanning, I can delete the latest point by pushing the Tri-State button left once, or delete all points by holding it to the left a little longer. Once I'm happy with the points I captured for an element, I can push the button to the right to confirm the element and start creating another one. When creating the points for a cylinder, there is one extra piece of information that is good to know. For the software to know if the cylinder is actually a hole or a shaft, the probe should be at an angle to the cylinder's axis when acquiring the points. But usually this happens automatically. The better workflow, since I already have a scan part, is to import a CAD with a measurement plan to the project and then work through it. I will get the CAD through the Quick Import. And then, with a right-click on the CAD and Import Measurement Template, I get the measurements. I wanted to start with an empty project, but it would have been better to have a project prepared with the CAD and measurements already loaded. To align the scan, I'll simply select it, and then go for a Best Fit alignment up here. The CAD should already be preselected as the reference object. Sometimes it is necessary to increase the quality level to get a good result. Then I can finish the alignment. And now I can copy and paste the measurements to the scan. I set up some of the geometry elements to be probed, so they're still complaining. To fix this, I will go back to the Scanning tab and select Update Probed Elements, which I will do now one by one, confirming the elements again by pushing the button to the right. You see that as soon as I confirm the elements, they are updated. And the measurements are updated as well. That was a nice workflow using both scanning and probing. But it is, of course, also viable to probe directly without scanning the part. Let me quickly show how that would work. No need for Scan 1 anymore. But I will create a new scanning object on this Scanning tab. Again, I'll copy and paste the measurements from the CAD. This time, however, I need to go to the Geometry Elements tab in this dialog and quickly uncheck and check the option to probe points on Scan Object. By doing this, I switch all geometry elements to be probed manually. In this case, I also want to toggle off the option Camera Follows Device, because initially the measurements will not be where the CAD is. I'll make the CAD slightly transparent, and then I'll click on Update Probed Elements again. Now all my measurements are updated, but not in the correct spot yet. The quickest way to solve this is by selecting the scan and then going for a sequential alignment. Here I can select different geometry elements to align by. For example, planes 1, 2, and 3 as primary, secondary, and tertiary mapping. And that's it. In this video, I showed you how to use an Absolute Arm in combination with the AS1 scanner and VG software to perform laser scanning and measurements. I hope I sparked your curiosity. Have fun trying it out on your own. I hope you enjoyed this video. You'll find a list of all our tutorials on our documentation landing page via Help, Show Tutorials. Plus, make sure to register on Nexus and make it your go-to place for sharpening your expertise. Get access to this video and other information material to get the best out of our software. And visit the VG community to exchange ideas, ask questions, and discuss topics with other users and our Hexagon experts. And stay up to date on the latest news and developments. Register now, a world of insight awaits. Thanks for watching, and see you soon on Nexus.